So first of all, the definition of direct variation is y equals k times x, where k doesn't equal 0. Because if k equals 0, there'd be no x, right? It'd just be y equals 0. Okay, so first of all, the constant of variation is what k is. It's that number in front of x. Okay, that's what the constant of variation is. It's also called the constant of proportionality because we're actually going to look today at how you can solve direct variation problems by using proportions. And then it's also known as the slope because we can graph these direct variation problems and we can get a line. Okay, so first of all, let's go ahead and look at this one. It says name the constant of variation for the equation. Then find the slope of the line that passes through the pair of points. So let's go ahead and start with the constant of variation. Here's my equation. Okay, this is my equation right here. So based on what I just said on the previous slide, what would the constant of variation be? 1/2, right? It's just the number in front of x. That's it. Okay, so the constant of variation right here, okay, is 1/2. Now what I need to do is find the slope. And so on Friday, if you remember, we briefly went over this, okay, and we counted 2 points on the graph. And so in this case, I have 2 points on the graph. And remember what I did? I found the rise, and I divided it by the run. So in this case here, what is my rise going to be? 3, and it's going to be a positive 3 because it goes up. Okay, and then my next one, I've got my run right here. What's the run going to be here? A positive 6 because it goes to the right. And so remember, slope is rise over run. So what is 3 over 6 reduced down to? 1/2. So we've just illustrated that the slope and the constant of proportionality are in fact the same. Okay, we just showed you how that worked. Okay, so with that in mind, I got a quick question for you on your expressions. Name the constant of variation in that following problem. Okay, name the constant of variation. Shouldn't take you very long. It should be one of those, boom, you see it, you should know what it is. Okay, so the answer is -2 because what did we say that the constant of variation is? The number before x. That's all it is. Okay? Not a hard problem. Okay, just look and you should know what the constant of variation is. So real quick, what would the constant of variation be here in this problem? 3. Okay, it's the number in front of x. So then now it says to graph. So there are 2 ways to actually graph this. We could use something known as slope and use that, but we're not going to quite yet. Okay, we'll hit that another day. But for right now, we're just going to go ahead and do a typical XY chart. Something you've done before, something that shouldn't be new. The 3 numbers I want you to always use are -1, 0, and +1. Always want you to use those. Okay, so -1, 0, and +1. Now all I'm going to do is I'm going to take each of those values of x and I'm going to plug them into the equation up above. So if x is -1 and I plug it in here, what do I get y to equal? -3. So then I'm going to put a dot at -1, -3. All right, now I'm going to plug in 0. If I plug in 0, what do I get? 0. So I'm going to put a dot at 0, 0, which is the origin. So far, so good? Next one, if x is 1, what does y equal? 3. So I'm going to put a dot at 1, 3. Now, if you've done this correctly, all of your points should lie in a line. If they don't, you've done something wrong. You need to go back and check your work. Okay, and all I'm going to do then is go ahead and connect the dots, and that's what your line will look like. So, if they all 3 don't lie in a line, go back and check your work, because they all will. Let's look at another one. Okay, y equals -2/3 x. -2/3 x. So once again, let's start with the old XY chart. So if I plug in -1, what do I get? +2/3. Okay? So then the question is, well, how do you graph 2/3? you just go up about 2/3 of the way to the number 1. Okay, it's kind of one of those approximation things. You probably aren't going to hit it exactly 2/3 of the way, but get it close. If I plug in 0, what do I get? 0. What did we get on the last one when we plugged 0 in? Oh, okay, just thought. All right, let's look at the next one. What do you get? Negative 2/3. Okay. And so what does your line do? It goes down. What did your line do on the last one? It went up. Did you notice anything different with the equations? This one is what? Negative, and it goes. Okay, that's an interesting thought. So first of all, graphs of direct variation. Now you already have that first star written down, so that's nothing new. Graphs of direct variation are in the form y equals kx, k cannot equal 0. The kicker here, though, is they always pass through the origin. Okay, every graph of a direct variation problem will pass through the origin. That's one thing to file away. Okay. So now I got some quick questions for you, so I hope you have your expressions handy. Okay, because these are going to be fast. These are multiple choice. Okay, so the first one, the first thought. This graph up here illustrates what type of slope, and I give you 3 choices, A, B, and C. If you don't know, take a guess. Give me your best guess on that. Does that one illustrate A, positive slope, B, negative slope, or C, constant? The answer is B. Why is it B? Because it goes down. That's right. Negative slope means it goes down. It's kind of like one of those things. Negative usually means like you lose money. Okay, and if you were going to look at a graph of you losing money, it's going to go down. Okay, not real good. This graph illustrates what type of slope? And the answer is A. Nice job. Now constant. Somebody asked me about constant. What would constant look like? A straight line across. Okay, it's going to go horizontal. It's not going to go up or down. Okay, that's something that holds its value. Okay, so let's go ahead and look at this problem right here. It says, suppose y varies directly as x, and y equals 72 when x equals 8. Write a direct variation equation that relates x and y. Use the equation to find x when y equals 63. We're going to do something a little different here. We're not necessarily going to write a direct variation equation per se. I'm going to show you how to solve these using proportions. So on your homework, you're maybe not going to have an equation that like the back of the book would say. Okay? What they're looking for is they're looking for something like this. Okay, but I'm going to show you how to use them using proportions because that relates to something that we already know. All right, so let's go ahead and look at this. It says y equals 72 and x equals 8. So when I write my proportions, I'm always going to put x on the top, y on the bottom. It doesn't matter. You can put y on the top, x on the bottom, as long as you do the same thing for both sides. And I'm going to use this statement right here. Okay, y equals 72, so that means 72 is going to go in the denominator. And it says x equals 8, so that's going to go in the numerator. So you're going to take one sentence, one statement, and write a fraction. So now I need to write the other half of the proportion. So I'm going to look at what else I'm given in the problem. And what else do they give me? 63. So is 63 going to go in my numerator here or my denominator? Denominator. And in my numerator, I'm just going to put x because that's what I'm trying to find. So now I'm going to cross multiply. So let's go ahead and take 8 times 63. What do you get? You're close. I wouldn't reduce first. You could. 504 equals, what do you get here? 72x. So how do you solve that? Divide by 72. What does x equal? 7. There you go. I mean, you could do that. I don't know in the long run if that would save you much time. On this one it works, but the majority of the time it might not. Okay, so With that in mind, here you go. Suppose y varies directly as x and y equals 98 when x equals 14. Write a direct variation equation relates to x and y. Use the equation to find y when x equals -4.
Yep. We can reduce, you don't want us to?
You can. I don't know if it's going to save you much time. I mean, proportions are generally ones where you can solve them pretty quick. And so the amount of time you spend in reducing in the long run, is that going to save you time? I mean, if you want to, try it. I mean, you might be really good at reducing and be able to get that to work. But like I said, in the long run, I don't know if it'll save you much time. Okay, so I need you to go ahead and enter it in on your expressions when you get it done. And the answer is actually -28. Okay, for those of you that had 28, you probably just forgot that -4 sign. Okay, it's one of those things, just make sure that your negatives, you don't forget those. But other than that, not bad. You should have had, for a fraction, you should have had 14 over 98 equals -4 over y. So, one of those things that when you cross multiply and divide, you should get y to equal -28. So the last thing we're going to talk about, and this is something you should already have in your notes. This is nothing new. We're just looking at it again. Distance equals rate times time. Remember, we looked at that with the train problems at the end of chapter 2. And so, real quick, it says the distance a jet travels varies directly as the number of hours it flies. And that should make sense because if you think about that, distance is usually in terms of miles, right? Okay, it's usually in terms of miles. And we usually do time in terms of hour. And so when we think about that, that fraction bar, what was another name for that? Per. So really this is miles per hour, that's all you're finding. Okay? And so it says a jet traveled 3,420 miles in 6 hours. All right, so let's think about that. 3,420 miles in 6 hours. So really, how fast was that plane going? What'd you get? You're right. 570 miles per hour is how fast that plane is traveling. So let's think about the next question. It says estimate how many hours will it take to fly 6,500 miles. So there's two ways to do this. First way, let's write a proportion just like what we just got done doing. In which case we would have 3,420 over 6 equals what? 6,500 over h. All right, so let's go ahead and cross multiply and see what we get. So what do I get here? 3,420h equals, what does this give me? 39,000? So then how do you solve it for h? Divide by 3,420. So how much will I get for time? 11.4 hours, okay? So obviously that took a little bit of work. Is there another way that might have been a little bit shorter that somebody could think of that I could solve that problem? And it might not have to do anything with proportions. Yeah, would you? Okay, you could estimate. What else? Okay. Is there another way? Something totally different than what I did here.
I did that, and then it's 6 times 6,500 divided by 320.
Is there any way else that I could do that? Yeah. Divide what? You're on the right. I think you're. Close.
It'd be because you want 6,500 now, so you take 3,420 and add it to it, so, and then you divide it
I want you to think about something real quick. Let's say, for example, I'm wanting to go to Kearney. Let's just estimate Kearney's 100 miles away. Okay, we'll just for estimate's sake say it's 100 miles. I think it's actually a little less. And let's just say I plan on driving 50 miles an hour. Okay. How long would it take me to get to Kearney?
2 hours.
How are you getting that? Adapt it to this problem. Tell me how else I could get 11.4. Yeah.
Divide your 3420 by 6, and then I'll stop
Divide what?
Divide 6,500 miles by 500.
There you go. There's another way you could have done that. And if you actually take 6,500 and divide it by your 570, you're going to get the same amount because that's your total distance. And then if you take that by how much you're actually going, your speed, that will give you 11.4 as well. So that's another way that you could have gotten that. Okay, so just one of those things, kind of want you to think sometimes outside of the box a little bit. So here you go, pages 185 through 186. What I need you to do is 10 through 26, the evens, 30, 32, 34 through 37. Okay?